Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about inverter generator. So let's dive right into it. Now first you have to understand what exactly is the problem with our normal generator system. Well, sooner or later most of us need either a portable generator or backup power systems, and it's kind of things that the moment your business starts to become big or you start to become dependent on electrical energy, you will end up investing in these things. However, even though these industries are being going on for 50-60 years, their power output, basically the sine wave that they are giving out, that's true sine wave, that's awesome. Problem is it has really poor control, meaning your frequency could change. It can go from 50 hertz to as low as, like, let's say 48 hertz to 52 hertz, and the voltage, well, that's lol. So you can literally have in India from 220 volts, it could literally dip to 170 volts and go as high as let's say 300 volts. And that was not an issue in olden days because every electronics we had was kind of bulky and robust, so to say. However, modern silicon based electronics, they are much more sensitive to dirty power. So you could, if you try to have this sort of generator unit and try to run your giant electronic equipment, you could mess things up. So fundamentally people don't like that, especially for sensitive equipments. And then there is a weird caveat with all these sort of generator system, is that they are only efficient at full load, basically almost at 80% or 90% of their load. If you run them, like, basically let's say this is a 5 kilowatt system, this is a 10 kilowatt system, and you are running at like almost 9.5 kilowatt, almost 4.5 kilowatt, they will be performing at their best. Basically price per unit of electricity produced would be the lowest. Now you may be like, hey, what will happen if I tone it down? Basically reduce load. Or let's say you were running an air conditioned room, went completely cold, and now AC is off. It goes on and off. Even if it is an inverter AC, it will like go work at high power at beginning, and then it's gonna be just maintaining that temperature. So you will literally have a high power demand, and then it's gonna go. The moment it goes to below, the power produced by these puppy will start to become expensive. Basically it's gonna burn more fuel compared to the energy it's producing. It will not go down. So that creates an issue where it's like nobody has like absolute fixed electrical load. So that creates an issue. Now all that issue stems from RPM. Now RPM is the basically, if you want clean RPM, basically clean electricity, you have to stable RPM. You have to have stable RPM. How do we achieve that in our actual grid? Basically we use huge things, meaning bigger the better. So at this point in time, you can literally go to power plants, even if they have small generators that are 100 megawatt, they will have multi-ton rotors connected to multi-ton turbines, and sometimes the total rotating spinning mass could be as high as 600 ton or even higher. Benefit of that is like there is no force on this universe that will stop that instantaneously. So if you are producing, let's say 100 megawatt power, and instantaneously somebody put a huge amount of load onto that system, let's say you started an induction furnace trying to melt steel or something like that, there will be huge load, but this will not slow down because inertia will absorb that impact, and then it's gonna slow down a little bit. So basically your frequency will go from 50 hertz to 49.998. now that will happen slowly enough that computers can detect it. Hey bro, somebody is putting some load, so they can open steam valves and maintain the RPM. That's how we achieve such a good electricity in our grid. However, if you think those things are expensive, that's not something that can be done easily. And on top of that, RPM directly controls the frequency, and that creates a scenario where it's like everything controllable on a generator system is just fuel flow. That's the only thing you can control, and consequence of that is the moment you change with fuel flow, you change the RPM. Yes, you will increase the basically torque value, but torque value never goes in a combustion engine like, okay, the RPM is, let's say 1500, it's locked at 1500, but torque value is going out down. That's not gonna happen. Like you can have like torque goes up exponentially, but RPM goes to 1600, but you will have RPM increase. So that creates a scenario where your frequency of the electricity produced will always be sloppy. The control would be very low, and to manage the basically, because there is a higher RPM, you will also have higher voltage. To control the higher voltage, generally what is utilized is basically field control. Basically the magnets that are spinning inside, not magnets, in electromagnets, you will want to tone it down. So hey, the voltage is starting to reach, let's say in India it would be like the moment it starts to exceed 250 volts, it's like whoa, most things can go boom at that that kind of voltage. So you'll be like, okay, let's tone down the field strength. Now that is something you can do, and many generators do have active voltage control. However, the moment you start to talk about low wattage system, basically 5 kilowatt or less, generally they don't have this sort of system. Yes, there are their systems that are like big ass generator units that are like 10 kilowatt or 50 kilowatts. those are amazing. Yes, they are literally gas guzzlers and they're really inefficient, but in terms of power quality, they're good. So that creates an issue. It's like for small applications, what the hell you to do? Either you use a dirty power, which could literally fly your electronics nowadays, or you just buy something super expensive which you can't afford. So that's why we have to use inverter AC. So inverter, the core of that inverter AC, basically this is the old system where you had a electromagnet in the center, which was the rotating basically electromagnet, and you had slip rings. Slip rings is sending electricity, DC electricity into the core, and you will control the intensity of it to control the voltage, and the RPM will control the frequency. Now all this gone. Take this, throw it away. Then you will have basically this is what we call rotating field type. So what we now you have is basically a BLDC motor. So if you have ever seen a large BLDC motor used for drones, is exactly like that. Control C, control V that. So it uses neodymium magnets, and benefit of that, there are no brushes. So you have two brushes here, you don't need any brushes. Fundamentally it reduces friction loss and electrical loss, so that's awesome. And because of the design system, because of the compactness of the equipment, this is basically the flywheel. So when you are talking about a normal motor, basically combustion engine and generator unit is this big. On this puppy, it's this big. Now you're like, how the heck it became smaller? Well, because the flywheel, every combustion engine, especially with one single piston, generally needs a huge flywheel. So they are like, why the heck just have flywheel, which is a dead mass, have that the rotor of the generator unit. So that rotor has like, you know, giant metal mass. On top of that, it has huge magnets. So it has enough inertia to act as a flywheel. So they're like, let's get combo benefit out of it. So your generator went from like this big to this big. It became smaller, easier, more portable. You have no friction losses, and if done correctly, you can achieve starter function with this, meaning that very single thing is it's a BLDC motor. So you can also use this to spin up the engine and start it. So you don't need an independent starter motor. All you need is a clever electronics for that and a battery. So that is extra advantage of utilizing this, and this is becoming more and more common in India, because India recently went you know, in gasoline and petrol system, we changed the basically emission standards, and to you know, basically coinciding basically starting with the same time, Honda, a large auto manufacturer in India, basically for their two-wheeler division, they started to introduce motor generator combo unit, which is basically a fancy BLDC motor. So it's directly starting the engine utilizing the BLDC mode, and then letting it run as a generator. So they do not have alternator and basically starter. They do not have two systems, they have one system, and that's also brushless. So it's far more efficient, far more simpler, and even it produces less pollution. So fundamentally everybody wins. Same technology is being used here. So basically, if done correctly, you will get a starter function also, and you will have a much smaller unit with the same amount of power output. So portable side actually becomes portable. It's not like you have to be, you know, Arnold Schwarzenegger to lift this puppy. So that's the whole point of this. So what comes after that? Well, it creates AC power. It generally creates three-phase AC system. If you have ever seen a BLDC motor, you always notice there are three cables coming out. So it creates three-phase. Now, why do you want three-phase? Well, even though generator output will be one phase, if you have three-phase, you will send it through what we call full bridge rectifier. And each rectifier, a full rectifier, generally creates two pulse. So you will have basically from one system, one phase, you will have two pulse. From three, you can have six pulse. Now 6 pulse is much cleaner compared to 2 pulse. So fundamentally having cleaner DC, so you will need less capacitor and less inductor to smooth out the power. So you always want as many phases as possible. And in case of, let's say, ultra high voltage DC, people generally take 3 phase, make it into 6 phase, and then they have 12 pulse rectifiers. So they have really clean DC. So same happens here. Now you take with AC, your BLDC output is AC. Now that AC goes into the capacitor, basically rectifier, gets added, smooth out with the capacitor and inductor, and then you create a new AC. Basically you are utilizing the inverter circuit there. Now what's the benefit of that? Because you are taking from a clean DC pool, you have proper control, meaning you can get proper sine wave with fixed frequency and fixed voltage, meaning these things are good enough that they can run sensitive electrical equipment, or running even inverter ACs, running things that require a lot of semiconductors. Basically it can be done. So it can even allow paralleling of generator depending on how it's built. Some generators could literally have a what we call grid tie inverter topology, where they're gonna sync multiple of them, or sometimes you will have a direct bypass where they are bypassing the inverter on one and dumping that energy into second generator, and then second generator is just converting at a higher load. Now you're like, why the heck you want to parallel these things up? Well, assume you bought one of them and then your load went up. Rather than buying a one bigger one, you can just buy another smaller one. And sometimes for redundancy point of view, that's better. It's like the likelihood of both of your generator failing at the same time is very low. So people do like this sort of paralleling the operation. It's not that feasible or practical, but it's one of those things that's like, it's better to have it rather than not to have it. So people do like the idea, and you get really good electricity from coming out of these puppies. So what are the pros and cons of the system? Well, they are far more expensive, but neodymium magnets are not cheap, so that do add up a cost. Inverter circuits that are good quality inverter circuits, they are also not cheap, because you can buy a square wave inverters that are super cheap, but you really don't want square wave coming out of a generator. You want sine wave coming out of a generator, so that makes it expensive. So there are fundamentally more components into this puppy that makes it far more expensive. And then because there are more things, it has higher servicing and maintenance. How be mindful, servicing interval is much higher because it has a fewer brushes and less components in terms of basically how many things it has to deal with. It does last longer, and not to mention better technology is used to building these things, so they generally last a much longer time. But they are one of those things. It's like, everything is awesome, but if it breaks, it does take a lot of money and investment to fix them. And what you gain out of for those consequences, first thing you get is high quality energy output, meaning you can run a direct PC desktops running on it without worrying about frying your equipment. So that's awesome. On top of that, it does allow lower power state, meaning, assume it this way, let's say most people in India buy this for, let's say, shopkeepers running air conditioned units. So because again, it's in daytime, you really don't want to have customers coming in an Indian heat where it's like, they want to come into your shop, which is like, covered with glass, it's just acting like a greenhouse. So you need air conditioner running. So this sort of puppy is really good for that. But here's the problem with air conditioner: once they cool down to a native state, they don't need to work as hard as possible. So at the beginning of the day, it will be like consuming 2 kilowatts of power. After that, it's like 2 kilowatts for a few minutes. 2 kilowatts of few minutes. That's what it does generally most of the time. Even with the inverter system, it will be like 2 kilowatts at the beginning, and then it will be like 500 watts just to maintain the temperature. So that creates a problem. It's like normal generator like that first 2 kilowatt load is awesome. The moment power went down, it's like the RPM started to idle up, and fuel flow, it can only control to so much. Here they don't have to worry about RPM because RPM is independent from the frequency output. So this can go into lower state, which they call eco mode. Almost all company calls it the eco mode. And benefit of eco mode is that it can actually allow the generator part of it, the combustion engine part of it, to spin down in RPM. So let's say the normal average RPM is 1500. Everything is fine, everything is dandy, but the moment it detects like, dude, nobody's using the electricity, they're like, okay, let's ramp down the RPM to 700. And because it's creating DC and then AC from that DC, it does not matter. Your output frequency is still the same, your output voltage is still the same. You don't have to worry about it. And because there are inductors and capacitors, so even if you directly started a big load, it will give them enough chance for engine to detect it. It's like, hey, somebody is drawing a lot of power, and then it will open the fuel valves, RPM will pick up, tada, more electricity. So you get high quality power, and it allows lower power state. And benefit of lower power state is better fuel economy, meaning if you are running this sort of generator, let's say a few hours a week, which is very common in India in many places, literally over a course of 1 month or 2 months, people start to benefit. It's like, dude, this really saved me money compared to a normal generator system. So yes, they are expensive, but they actually justify their cost, and very quickly. Specifically, if you have varying power loads, they will like literally shut up and take my money. Not buying them would be waste of petrol. And at this point in time in India, petrol prices are around 94 rupees per liter. So people are switching to this, and almost all major manufacturers of generators units, they are just providing inverter units. They have closed down all the basic inverter systems, and you can only buy basic units from third-tier manufacturers. So this was my presentation on inverter generators. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.